Welcome back to the deep dive. Today, we're not just skimming the surface. We are really plunging deep into the ingenious mechanics that make modern flight possible. Just imagine for a second trying to wrestle this, gargantuan, multi-ton aircraft tearing through the sky at incredible speeds with just your own strength. Like picture trying to manually move a giant wing section, generating thousands of pounds of force with just your arm. It sounds, impossible, right? A real Herculean task. And you'd be absolutely right. So today we're diving into something absolutely crucial for your ATPL theory exams. Our mission here is to really distill the key knowledge, hammer home those essential concepts, and give you a clear framework. The goal, to help you tackle those exam questions on powered flying controls with real confidence. It's not just about memorizing stuff, it's about truly grasping the principles, understanding how these amazing machines translate a pilot's subtle touch into precise, safe, powerful flight. That's fundamental knowledge for you.
Absolutely. And what's so fascinating here isn't just the mechanics, though they are clever. It's the sheer ingenuity, the layers of design thinking applied to make sure flight is precise and safe under these immense aerodynamic loads. This is foundational knowledge, especially for exams where, a deep conceptual understanding is just non-negotiable. We'll break down why we need powered controls, look into how they actually work, explore the critical role of artificial feel, which often gets misunderstood, and then step into the world of fly-by-wire. And finally, we'll cover the vital safety redundancies. These are absolutely paramount in modern aviation and something every pilot needs to understand inside out.
Okay, let's unpack this fascinating and really quite sophisticated world of how we command these incredible machines. So let's start right at the beginning. What was the problem that powered flying controls actually solved? Why did we even need them? Back in the early days, small biplanes, slower speeds, direct mechanical links were fine. Push the stick, a cable pulls the elevator. Simple.
Simple, direct, yeah. But as aircraft got bigger, faster, heavier, that whole approach it stopped working. It became completely untenable. You've nailed the core issue. It boils down to the immense aerodynamic loads. Think about the control surfaces on a modern wide-body jet. They're huge. An aileron designed to deflect enough air to roll that massive plane. The force of the air pushing against it, especially at, say, Mach 0.8, is just staggering.
Right, we're talking tons of force, aren't we?
Easily.
Yeah.
And it's not just size.
It's the speed, too, right? That makes it worse.
Dramatically worse.
Yeah.
Speed increases dynamic pressure, remember, and that goes up with the square of the velocity. So a bit faster means way, way more force needed.
So the pilot would need, what, hundreds of pounds of force on the stick?
Maybe even thousands in some scenarios. It's simply beyond human strength for sustained, precise control. Forget about it. And that's where regulations come in. Things like CS25. The certification specs for large airplanes.
Okay, rule book.
Exactly. It sets the standards. It says how strong the surfaces must be, but crucially for us, it limits the maximum stick force a pilot should have to exert. Usually around, say, 60 pounds for primary controls in normal flight. That's the design challenge. Move something resisting tons of force with just 60 pounds of input.
So the solution, the clever bit, is power assistance, using hydraulics or electric power to sort of amplify the pilot's input.
Precisely. To reduce those massive loads down to something manageable. It's like power steering in your car, but obviously on a much, much bigger and more critical scale. That force multiplication is essential.
And hydraulics have been the main way to do this historically.
Overwhelmingly, yes. Hydraulic systems pack a huge punch, high power density, great responsiveness, handle massive loads. We're talking systems running at 3,000 psi, sometimes more. Electric systems are definitely coming up, especially with fly-by-wire, but hydraulics have been the workhorse for decades.
Okay, this brings us to a really important point, especially for your exams. The difference between powered and power-assisted. Sounds similar, but it's a big deal, isn't it?
It's a fundamental distinction, yes. It changes how the pilot connects with, and, importantly, feels the aircraft. A fully powered system, sometimes called irreversible, means hydraulic pressure directly moves the control surface. There's no mechanical link carrying load back.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.